We're going to continue our discussion of talking about probability distributions with one that's possibly the most common probability distribution we see in other contexts and when we're measuring things in the world, and that would be a normal distribution. So we're talking about the normal, write that a little bit neater, the normal distribution, or the normal model, sometimes it's called, but when something is distributed normally. So this is, like I said, one of the most widely used probability models for a continuous numerical random variable. So we're talking about continuous distributions. The notation that we use for a normal distribution is this symbol right here. It's the Greek letter mu, and it tells you that you're looking at the mean of the probability distribution. The one below it is called sigma. So that's the lowercase letter for sigma, and that represents the standard deviation of a probability distribution. So when you see the notation with a capital N, that indicates that you're looking at a normal distribution with a mean of mu and a standard deviation of sigma. So they have to give you those two things so that you can work with the distribution. A few important features of a normal distribution. It's symmetric, so they're always symmetric when you talk about like a bell-shaped curve. There you go, they always follow a bell-shaped curve. You remember we talked earlier in the course about distributions that are symmetric, and we just kind of use symmetric as a generic term. And we can have distributions that are symmetric that aren't normal, but all normal distributions are going to be symmetric and follow a bell-shaped curve, and they will all have a single peak. They're always unimodal, have a single peak at their center. Two things that distinguish one normal distribution from another are the population mean, so the mu represents the mean, and the standard deviation is represented by sigma. So a quick example here, it says, what is the mu, or the mean, the mu, of each of these normal distributions? So they're showing you in this picture, we've got two distributions, one with a really tall peak and one with a little bit of a shorter peak. And they're just asking you to kind of estimate some of this information in this example. So the mean for both of them would be right at the center, literally, because it's a symmetric distribution. So I think for both of these, we can say fairly confidently that the mean is 0. Approximate the standard deviation for each of these normal distributions. So the spread, remember we talked about spread back in chapter 3. The mean for these two distributions is the same, but the spread is different. Which one looks like it's got the larger spread? Hopefully you see that that's the one that's a little bit flatter. So that flatter graph indicates it's going to have a little bit of a larger spread or a larger standard deviation. And so if I had to estimate, I would say the standard deviation is maybe 2 units. So this would be 1 standard deviation at 2, 2 standard deviations at 4, and 3 standard deviations at 6. So let's say for the one that's in, let's say the larger one, I was going to say in blue, but I think yours is probably not color-coded. The larger one, I could say the sigma is 2. And then the smaller one, the one with the bigger peak, the standard deviation for that looks to me like the standard deviation is about 1. So 1, 2, and then maybe 3 standard deviations there. So the smaller one, the standard deviation is 1. Don't get too hung up on how I'm getting the 2 and the 1. If you're a little fuzzy on that, do not worry about it. As long as you can see right now that the one in blue is the one with the larger spread because it's more spread out and less clustered around the center than the one in red. What is the total area under each curve? Well, for any continuous distribution, the total area, remember from the last section, is always 1. So they're both going to have an area of 1 contained underneath their curves. The next example, we've got different means, but they have the same standard deviation. So we're comparing, it looks like men versus women for heights. And so the mean for each of these distributions. So for women, and I'm just kind of estimating where I think it is, start where that peak is and go down. I don't know, I'm guesstimating it's around 63, so I'm going to say the mu for that one is about 63. And then for men, same thing, we're going to start at the peak and just kind of go down. I don't know, I'm guesstimating about 68. Approximate the standard deviation for each of these normal distributions. So for the women, and I truly am just estimating this, but for the women, I would say if their mean is right in the middle at 63, and their distribution goes out. Remember, 3 standard deviations pretty much covers the entire data when you have a symmetric distribution. Remember from the empirical rule from earlier in the course. So if 3 standard deviations takes me to there, and that's about maybe 72, that would be a distance of 9. And so 9 divided by 3, I'm guesstimating that the standard deviation is about 3 units. And we can talk about that a little bit more in class. If you're a little unclear on how I got that, do not worry. I do want you to just make sure that you see that the standard deviation or the spread for both of the distributions looks like it's about the same. And then again, what is the total area under each curve? Of course, that's going to be 1. All right, so let's look at an example. The normal model, okay, so what does this mean? This tells you we're looking at a distribution that is normally distributed. The first number, remember, is the mean, so 64 is the mean, and sigma is 3. Gives a good approximation of adult women's heights in inches. Find the probability that a randomly selected woman from the U.S. is between 62 and 67 inches. So one thing I really want you to get in the habit when you're doing these assignments, get paper out, and I want you to start drawing the distributions. That's going to make things easier the harder these problems get. So I'm just going to make a quick sketch here. It doesn't have to be perfect. It's just for you so you can kind of see how everything's laid out. So the mean is 64, so that's going to go right in the middle. And then they want me to look at the range from 62 to 67 units. Okay. So if you'll recall from the last section, remember if it's a continuous distribution and we're looking for the probability that we're between 2 units, that would involve the area underneath the curve. So the probability, let's use the notation, the probability that x, if that's my height, is between 62 and 67 inches. That would be our notation. So x is between 62 and 67 inches. That would be found by looking at the area under the curve. Well, a normal distribution is always going to have, we know the total area is 1, but to calculate the areas, we can't use like standard geometry or anything like that. So in this case, we're going to have to use StatCrunch to figure this out. If you have your computer out, I would really recommend that you go through these steps with me. Unfortunately, with the software, I can't show you the steps, but let me at least talk you through them so you know what to do. So to figure out this probability using StatCrunch, we're going to have StatCrunch calculate this area for us, and here's the information that we need to put in. We need to go to the Stat menu and then go to Calculators and then select Normal Distribution. So Stat, Calculators, Normal Distribution. And then you're going to ensure that the button Between is checked. The reason I'm using Between is because I'm looking for a probability that's between 62 and 67 inches. Enter the mean. You have to tell StatCrunch what the mean and the standard deviation are. So the mean of 64 and the standard deviation of 3. And then you need to tell StatCrunch what specific values you want it to look between 62 and 67, and then click on Compute. And so in StatCrunch, I've gone ahead and done this, and I am getting a probability of about 0.774. So I really recommend that you go ahead and do that and make sure you get the same number as me. You should be getting about 0.774. So that means there is about, if we think of it as a percentage, we could say there's about a 77.4% chance that if we select a random woman from the United States, that their height is going to be between 62 and 67 inches. Okay? And then here's, oh, by the way, here's what you should see in StatCrunch. So notice, by the way, that this is similar. Now, I drew mine so it's a little more symmetrical. So my graph is certainly off. But if you look at what's in StatCrunch, this is the screenshot you should be getting. It should fill this in so you can see that what you sketched matches what you should have. Let's do another one. It says, research has shown that the distribution of newborn Pacific harbor seals' birth lengths is approximately normal, with a mean of 29.5 and a standard deviation of 2.5 inches. Find the probability that a randomly selected harbor seal pup is longer than 31 inches. So notationally, we're saying we want to know the probability that if we choose a randomly selected harbor seal pup, their height is going to be more than 31 inches. That's what we're looking for. So let's make a quick sketch of what we're working with. And so I'm going to put the mean right in the middle. So the mean was 29.5. And then 31 would be to the right of that. So I'm just going to pick a spot and stick the 31 there. And I want to know the probability that a randomly selected pup is longer than 31 inches. So I'm going to shade in the area that's to the right. Thinking about these areas and which direction you're shading in and how much you're shading approximately is really, really important. That's why I really want you to draw the graphs every time you do these. So to calculate this area, again, this is a weird area. I can't do it using geometry, so I have to use StatCrunch. So I'm going to go to StatCrunch, and I'm going to put in this information, stat, calculators, normal. Make sure you go through this with me. Ensure this time that the button is standard. So before you clicked on between, now you're going to click on standard. The reason you're doing that is because you want greater than a particular number and not between a lower bound and an upper bound like we did in the heights example. Tell them the mean and the standard deviation, enter that you want it to be greater than 31, and then click on compute. And notice that that sketch is similar to what I have up here. And so the distribution, the area for that is about 0.274. So our probability, if we want to go back up here and just fill this in, our probability was about 0.274. And you can write it as a decimal or you can write it as a percentage. It's up to you. Of course, in my stat lab, they're going to be particular about how you put the answers in. But that, as a percentage, would be about 27.4%. Okay, now remember that we're talking about a symmetrical distribution, right? So a normal distribution is certainly an example of a symmetrical distribution. So the normal model still follows the empirical rule. Remember we talked about the empirical rule back in chapter 3, and that rule applied to any symmetric distribution, so of course it's going to apply here as well. So we can use StatCrunch to help us figure out probabilities and be more precise with our answers, but sometimes we need something that's just a quick estimate and we don't have access to technology, and so the empirical rule will help us do that as well. Let me remind you of what the empirical rule said. It said that 68% of the data falls within 1 standard deviation of the mean. Remember that from earlier in the course. 68% of the data was within 1 standard deviation of the mean. There we go, 68%. 2 standard deviations, do you remember what that number was? 2 standard deviations contained 95% of the data. And then 3 standard deviations contained 99.7% of the data, or you can really just estimate it and say 100%. In practicality, pretty much all the data will fall within 3 standard deviations of the mean. So let's use that to solve some problems. So here's a picture, remember, of what that looked like. If the mean is in the middle, 1 standard deviation below to 1 standard deviation above, that's the 68%. 2 standard deviations below to 2 standard deviations above, that's the 95% of your data. And then almost all of it falls within 3 standard deviations. So let's use an example here. It says the chest measurements of 18-year-old male footballers is normally distributed. They have to tell you it's normally distributed, first of all, so that's got to be in the question. It's normally distributed. The mean is 95 centimeters and the standard deviation is 8 centimeters. Find the percentage of footballers with chest measurements between 87 and 103 first. So how can we figure this out without using technology? Let's draw a picture and let's label the important information. So the mean is right in the middle and the mean was 95. And so I'm going to go ahead and label certain tick marks this time. So I'm going to go 1 standard deviation below the mean and 1 standard deviation above. So if the standard deviation is 8 centimeters, 1 standard deviation below would be 87, and then 1 standard deviation above would be 103 centimeters. The first question, it's asking us specifically for those numbers. It's saying the probability that a randomly selected footballer is between 87 and 103. So the probability that somebody is randomly selected is between 87 and 103. Since that's exactly 1 standard deviation below and 1 standard deviation above, I can use the empirical rule to answer that part and just say it's 68%, approximately 68%. How about part B, 103 to 111? So the probability that a randomly selected footballer is between 103 and 111. So let me go back to my graph and let me put another tick mark for 2 standard deviations below the mean. So subtract 8, the standard deviation, from 87. That would give me 79. Above the mean, add another standard deviation. That would get me to 111. So where am I at? So 111 is 2 standard deviations above the mean. 103 is 1 standard deviation above the mean. So I'm looking at this area right in here. And think about, it should be less than half, right? Because it's less than half of the graph. So it should be a pretty small number. It's definitely less than half. How could we figure this out? Well, what I would do is I would say, okay, we knew 68% of the data was in between these two marks. We also know that 95% of the data is within 79 and 111. So what can I do to get the part that's shaded in red? Think about how you can do that. Well, if you think about cutting out this middle section, subtract that 68% off, what is left for the tails, the remaining areas, the part that's shaded in red, and this tail down here. So what I'm going to do is I'm going to take, let's see, I'm going to take the 95 and I'm going to subtract 68. So let me jot down what I'm doing here. So I've got 95, cut out the 68%, and that leaves me with 27% for this little area here and this little area up here. Well, I don't want both of those, I just want this area. And because of the symmetry of the graph, we know those areas are going to be the same. So I'm going to divide that by 2 to get the area I actually want, and that puts me at about 13.5%. Okay, so there's about a 13.5% chance that if I randomly select a footballer in this group, they're going to be between 103 and 111 centimeters.